And when it runs, what's it going to do? Oh, it's going to output the first time around, it's going to output a paddle. And that gets sent to the output of this whole part, which is here. And then that paddle business is going to get sent to the GUI to here. And then this daemon is going to send it off to the GUI browser client. And it's going to draw a paddle on the screen. Sweep right here. And at the same time, by convention, the way I built this is so it sends out. I just talked about the first time. So the first time and every time afterwards, it's not going to send the paddle command out. It's going to also send. The first time it's going to also send a ball command, and every other time it's just going to send ball commands. And those ball commands are going to go back out to the GUI and draw the little red ball on the screen at an XY given by the JSON that's output at this point. And it was just convenient to parse out the X value. At that point, we remember we saw the ball going from left to right and back, and that's basically just the change in X. The X component I want to shoot to here, and I stuff it into a 1 then 2, so I make sure that do I need this even? Well, this is the way it's done at the moment. I may clean this up later. I may not need this component. I was experimenting, trying to figure out what my problem with logic was, and I put this in to see if it was an ordering problem. Then it wasn't. Well, yeah, no, it wasn't. It was a recursion problem. These diagrams run to completion. And so if you put in a feedback loop, which is what I had at that time, the feedback loop just ran forever. It was an infinite loop. And I needed to break the loop by sending it out and then sending it back in, which is what happens here. So I send it out, it comes right back in. But because the queuing nature of the system and so on, this output and that output go to the output. They get processed at that level and then thrown back into this part, and it breaks the infinite loopness of the thing. So the X flows out, comes back in here into the, basically when you write a loop, you write something like if expression blah 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 or while expression blah blah blah. This part, loop test, is the blah, 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 which is basically a little state machine that says if X is at the leftmost boundary, then put a reverse. If it's at the rightmost boundary, put a reverse. And always output a pulse that says send out another ball position. So what happens here is this thing starts off, it sends out a ball position and sends out the X of that ball position. It comes back here, and if the ball hasn't banged into the left side or the right side, it just sends another keep going out here. And that increments the ball position and sends it out here. And that moves the ball to the right by 1 step. I decided to make steps units of 10, the width divided by 10. And so like when we get to, I think the width was 800, so when we get to 880, no, we get to an X of 800 or greater, then the X is going to come here, this tester is going to see that it's 800 or greater, and it's going to fire out do a reverse on that. And internally, that just multiplies the increment by -1. The next time it gets a reverse, it's going to multiply the increment by -1 times -1, which is +1. And that moves it from left to right. The -1 moves it from right to left. So we should see x is going from 0 up to 800, and then from 800 back down to 0. And reverses popping in. So we should see 0 come out here, 800, so 80, 160, all the way up to 801, or 800, whatever. It's not 801. And then we'll see a reverse, and we'll shoot out the thing. And because this is all concurrent stuff, you don't know for certain, or you shouldn't need to know for certain, that the ball position is within the bounds. So we may have hit 800, shot out a ball position, or we may have gone to 880, shot out the ball position, and then realized, oh, that's over the right edge, let's send out a reverse. And so what we've got in here is a little state machine. I think it's like a Schmidt trigger of the hardware ilk that says once it crosses from lower to higher, crosses 800, so it goes from 720 to, goes from 800 to 880. It will wait until it goes back from 880 back to 800 or 780 or whatever the logic works out as, before looking for a 0 crossing. What was happening, if I don't put in the Schmidt trigger, it just puts a reverse every time. I'd say, is the ball position greater than 800? And as soon as it went over 800, the ball position was always over 800. So it was 880, 800, 880, 800, 800. And it would send out a reverse on every one of those. So this thing would shoot out an 880, get a reverse, shoot out an 800, get a reverse, shoot out an 880, get a reverse, shoot out a 800 and get a reverse, and so on. That's what happened. So the internals of this are a little Schmidt trigger. We can write that in normal if then else logic. I drew it as a little diagram, and then coded it up from the diagram. And I'll show you the diagram in a moment.